Welcome back, GED scholars and math warriors, to Algebra 104, Part 3, the case of the inequality enigma. Folks, if you have not watched Algebra 101, 102, 103, 104, Parts 1 and 2, please make sure you take a peek at them. I understand if you don't want to watch the whole video, if you already know what they are covering, but just review it in order to better understand the videos that follow after that series. And if you haven't already, please make sure that you visit GEDtalk.com/resources for the free worksheets. Please remember that whenever we drop a video, there is going to be a worksheet that goes along with that video. So if you run into a problem with the worksheet, please make sure to either contact us through the website or go to the accompanying video and leave a comment, and I'll be able to address that. But let's go ahead and get started. So an inequality is a math statement that connects two unequal expressions. And the way we know that we are looking at an inequality expression is that we are going to see one of these four symbols in the expression itself. This first symbol that we see in the top left represents the is greater than. So whenever we see this symbol, the point of the symbol, or the arrow, if you want to refer to it as an arrow, will always be pointing at the smaller number. So if I was going to use this symbol, which represents is greater than, my large number is going to go on the left and the small number will go to the right. So this would read 8 is greater than 3. Below it, and go ahead and skip over the dot, folks. We're going to talk about the dots in a second, but let's look at the four different symbols first. So the symbol below it is the symbol that will be used if the expression is sharing when a number is less than another number, which means my small number is on the left, the point of the arrow is pointing at it, and the large number is on the right. Moving over to the right, we see the is greater than symbol, but below it, we notice that there is a line. Whenever you see the line underneath the symbol, you're going to read it as is greater than or equal to. But the same concept is true with the symbols that didn't have the line underneath it. The point of the arrow will point to the lesser valued number. So when we have the symbol and I have 8 on the left because it's greater than 3 over here, I would read it as 8 is greater than or equal to 3. Below it, same concept as what we saw on the left, but notice there is that line underneath it, which makes the saying is less than or equal to. Same concept, arrow is pointing towards the lesser number, which is going to be 3, and the larger number is 8. Some of you might have remembered when you were learning this in school that the way that you remembered the symbols is that it was pointing or it was eating the larger number. Because you might have learned in school that, hey, just imagine it's an alligator and the alligator is going to go for the larger number. So if you're like, I'm an adult now, why would I remember it that way? Because sometimes, folks, it's easier to remember things when there's animation. So now when it comes to these dots, the reason they are here is because inequalities can at times be shared on a number line. So whenever you have an inequality where it might say x is greater than 2, well, what's going to happen is that I know that, let's say 0 starts here and I have 1 and this big dot is on my 2. The reason it's just a white dot is we want you to know that whenever it's just the is greater than being used, like it is right here where it's x is greater than 2, on the number line, you're just going to see a white spot on that number, and then the line will get darker, moving towards what the value of x could be. If the problem is x is greater than or equal to 2, instead of having just that white dot, you're going to have a black dot instead. So the dot would fall on the 2, and then the rest of the line to the right, because those are the potential values of x, will be dark or it will be bolded. You might see 3x plus 2 is less than 8. So we know that we need to solve for x and we need to get the variable by itself. The only difference here, folks, is the fact that instead of that equal sign, we have this less than symbol that's hanging out there instead. But we would go ahead and take care of this the same exact way we would take care of the other algebra problems that do have the equal sign. So step 1, do the opposite. Let's go ahead and subtract 2 from both sides. It's going to cancel itself out on the left. On the right, we'll get 6. 8 minus 2 is 6. Bring down the rest of the equation. So now I have 3x is less than 6. do the opposite of multiplication. We do division, it cancels itself out. Now we have x is less than, what's 6 divided by 3? 2. So the answer is x is less than 2. If we were to draw this on a number line, and I'm going to start it at the middle, because x is less than 2, I know that everything that is to the left of the 2, which is less than 2, is going to be part of the answer or the possibilities of what x is. So on my number line, I'm going to make it bold. On the 2 itself, I'm going to drop a white dot to let my viewer or the reader know that this is the answer for when x is less than 2. This white dot is representing that it is only less than, because if it was less than or equal to, this dot would actually be black. So we have negative 2n minus 5 is greater than or equal to 3. So let's go ahead and solve for n. First thing I'm going to do is bring the 5 over. So I'm going to add 5 on the left so it cancels itself out, which means I add 5 on the right. So I have negative 2n is greater than or equal to 3 plus 5 equals 8. Now I need to divide. So I'm going to divide by negative 2 on the left to cancel it out, and then I'm going to divide by negative 2 on the right. This is where I'm going to stop. And folks, if there was ever a moment in a YouTube video that you scrolled through and you made sure to stop and listen to, this is where you need to listen. Whenever you multiply or divide an inequality by a negative number, you have to flip this inequality. So we're going to do n is less than or equal to 8 divided by negative 2, which is going to give me negative 4. So once again, I'm going to say when you multiply or divide by a negative number like we just did, the inequality equation has to flip, you guys. You have to flip it, because if you don't, your answer is going to be incorrect. And I would always suggest that you go ahead and you plug in a number that is either greater than or less than what you found to see if it fits the equation. So let's go ahead and plug in negative 5 for n to see if the problem works out properly for us. So negative 2 times negative 5 is going to give me 10. 10 minus 5 is going to give me 5. Well, let's bring down the rest of the problem. So 5 is greater than or equal to 3. And since this is a true statement, we know that our answer, that n is less than or equal to negative 4, is correct. So next up is a compound inequality, and that's just going to be when two inequalities are basically combined, just like it says. So you might see 3x plus 4 is less than 5x, which is less than 16 plus x. And if you're like, how would I even solve this? Well, notice that both the left side and the right side equations have this 5x in common, right? The relationship they have to the 5x is being represented by these two inequality symbols right here. So when you want to solve for it, you're going to split this up. You're going to split the compounds up. And so we're going to have 3x plus 4 is less than 5x. And then we're going to have on the other side, 5x is less than 16 plus x. And then all you need to do is solve for the x. So I see like terms. I see a 3x and a 5x. So I want to combine my like terms. So I'm going to subtract 3x on the left. I'm going to subtract 3x on the right. So now I have 4 is less than 2x. Now I need to divide in order to get the x by itself. So on the right, I'm going to divide by 2. On the left, I'm going to divide by 2. So then I get 2 is less than x. The other equation, I have like variables and I want to get them together. So I'm going to subtract the x from the right and I'm going to bring it over to the left side. So 5x minus 1x will be 4x is less than 16. Divide 4 on both sides. So 16 divided by 4 is going to be 4. So x is less than 4. So the answer for this problem is going to be 2 is less than x, which is less than 4. And what we're being told, folks, is that x, because it's a variable, we don't know what number it's standing for, but what it's saying is that it's going to be a number greater than 2, because 2 is less than whatever this number is. But x, whatever number it is less than 4. So what number do you think x is? You said, isn't that 3? Well, yeah, folks, it could be 3 as a whole number, but you have to understand that there's decimals, right? There's numbers in between. 2.1, right? It says x is greater than, or 2 is less than x. Well, x is greater than 2. So it could be 2.1, 2.2, 2.3. So don't automatically think, oh, it has to be that whole number, because there's all of those decimal points in between as well. Let's look at another one, folks. Let's look at 3x minus 7 is greater than 5. Remember, your symbol, wherever it's opening up to, that's the greater side, because it's like an alligator going after the larger meal. So I need to solve for this. Get x by itself, add 7 to both sides, cancels out on the left. 7 plus 5 will give us 12, so 3x is greater than 12. Divide by 3 on both sides, x is greater than 4. So if we need to draw this on a number line, or they ask you to choose the number line as the answer, you know that because it's just saying x is greater than 4, that it's going to be a open white dot. We would draw the dot right there. X is greater than. So it has to be all the numbers to the right on the number line. And they might have this section of the number line bolded for you. Like you can tell the difference. So let's look at negative 2x plus 9 is less than 1. So let's start solving for the problem. Minus 9 on both sides. 1 minus 9 gives me negative 8. Negative 2x is less than negative 8. Now I need to divide by negative 2. What did I just do? I divided by negative 2. Sound the alarms. What does that mean? What happens to this inequality symbol? It flips. It flips the other direction. We're going to draw it nice so you can see that. So I have x is greater than, well, what's negative 8 divided by negative 2? We get 4. X is greater than 4. If they give you the answer on a number line, folks, remember, we have our number line. Negatives are to the left of the 0, positives are to the right. It's just a greater than symbol, no equal to, which means we are going to see a white dot, and then the line towards the possible answers x can stand for, or any variable could stand for, will be made in bold for you, like you see on the screen. And let's go ahead and do one more compound inequality so you know what you're doing. So I might get 30 is greater than or equal to 5 times x plus 4, which is greater than or equal to 10. First and foremost, folks, let's take care of what is happening in the middle, because nothing is happening on the ends. So we have 5 times x, which is 5x, 5 times 4, which is going to give me 20. Now I want to split up the compound. So now I have 30 is greater than or equal to 5x plus 20. And on the other side, I have 5x plus 20 is greater than or equal to 10. So let's go back to the left side of the equation and let's solve for x. Let's subtract 20 on both sides. Divide by 5. So we have 2 is greater than or equal to x. Go to the right and solve for the other half of the compound. Minus 20. 10 minus 20 will give us negative 10. 5x is greater than or equal to negative 10. Divide by 5. Negative 10 divided by 5 will give me negative 2. So the answer for this problem is 2 is greater than or equal to x, which is greater than or equal to negative 2. Folks, I'm going to highly suggest you really understand how to read your answers, because you may not see it written out like this, the way I have it on the screen. They might flip it and they might say negative 2 is less than or equal to x, which is less than or equal to 2. And both of these are saying the same exact thing, okay? Because it's true. Well, 2 is greater than x. So down over here, we see x is less than or greater than 2. Well, if 2 is greater, then x is less than. Does that make sense? I hope it does. If not, please drop a comment down below and I will make an attempt to explain that again. But both of these are sharing the same exact information. They are sharing the same exact answer. So let's go ahead and try a different problem. If I have 6x minus 2 is greater than or equal to 3 times 2x minus 5, let's go ahead and see what we can do. So on the right side, I notice that I can distribute the 3 to the other terms within the parentheses. So let's go ahead and do that. 3 times 2x will give me 6x. 3 times negative 5 will give me negative 15. And let's go ahead and bring down the rest of the equation. So now I know I need to get my variables to one side. But anybody see what I see where there's going to be some type of problem? Well, let's just go ahead and work through the problem and address it when we get there. I want to get all of my variables on the left side. This will cancel it out on the right side. I'm going to subtract 6x on this left side. Well, folks, the same thing is going to happen. So now my variables are all gone because 6x canceled out 6x. So now I have negative 2 is greater than or equal to negative 15. Well, and that's true, right? Negative 2 is greater than negative 15. And this is always going to be true. So no matter what value of x you pick, it doesn't affect the truth of the inequality anymore. So the conclusion is, well, we ended up with the true statement without any variable left, right? The x's were eliminated on both sides. The solution is all real numbers. In other words, every value of x satisfies the original inequality. Thanks for watching Algebra 104 Part 3, the case of the inequality enigma. Please remember, folks, to also visit GEDtalk.com/resources for the free worksheets. Practice makes permanent. And if you haven't already watched the other algebra videos, please make sure you take time to review them. Even if it's just skimming them through, at least you're paying attention to information that you will see on the math exam. Folks, you know what you're doing. Keep your head up. You got this.